This video will be covering topics related to the line focus principle. The production of an X-ray photon is not very efficient. In fact, nearly 99% of the energy created from a single exposure is in the form of wasted heat. Within the anode target, the area and where the majority of this heat is produced is called the actual focal spot. I always remember this relationship since anode and actual focal spot both start with the letter A. Directly perpendicular to the actual focal spot lies the effective focal spot. The effective focal spot is the area in where the X-ray photons produced at the actual focal spot are projected towards the patient. The size of the effective focal spot is directly related to the angle placed on the anode target. In other words, changing the angulation of the anode angle will also change the size of the effective focal spot. The line focus principle simply describes the relationship between anode target angle and effective focal spot size. Understanding the line focus principle is important since the effective focal spot size is directly related to image quality. For example, decreasing the anode angle decreases the effective focal spot size, which increases spatial resolution. So would it make sense to just produce all X-ray equipment with small anode angles? Not necessarily. One major drawback to utilizing small anode angles is that as anode angle size decreases, that is, gets smaller, the ability of the anode to tolerate high exposure outputs also decreases. Another drawback to utilizing small anode angles is that as anode angle size decreases, image field size also decreases. The line focus principle is especially useful when producing diagnostic X-ray equipment. For example, an X-ray tube used for mammography needs a small anode angle since mammograms must have a high degree of spatial resolution. Alternatively, X-ray equipment used within fluoroscopy uses large anode angles since these pieces of equipment must withstand multiple large exposure outputs as well as utilizes large image field sizes. Finally, standard X-ray equipment used for traditional diagnostic imaging falls between mammography and fluoroscopy since these pieces of equipment must be able to produce high-quality images along with varying exposure outputs and imaging field sizes. Here's an example of a question you may see regarding the line focus principle. If you guess C, then you are correct. The fundamental principle behind the line focus principle is that the degree of angle placed on the anode target directly affects the effective focal spot size.